want to talk briefly about torque and horsepower. Everyone sort of understands horsepower, but not everyone really understands torque. Engines do not produce horsepower, they produce torque. And torque is the force, basically it's measured in foot-pounds. So if you imagined a wrench on the back of the crankshaft of the engine that's 1 foot long, and if the engine was producing 100 foot-pounds of torque, that'd be 100 pounds force twisting around in a circle on the back of the engine. Now if the engine produces 100 foot-pounds of torque at 1 RPM, that's producing a certain amount of work. It would take the Land Rover up a hill relatively slowly, but it could still pull a very heavy load because the torque is there. Now, if you take that same 100 foot-pounds of torque and spin it at 1,000 RPM, well, you'd fly up the hill. The same weight, the same force, the same torque is there, can carry the same load, not taking into account perhaps wind resistance, but ignoring that. So it can do the work a lot faster, therefore more horsepower. So horsepower is really just torque times engine speed. So when you think of torque, it's really the torque that's the magic in what an engine produces. So let's talk about torque curves a little bit. You've all seen torque curves, right? Let's do just a quick little graph here. Start from 0, 1,000, 2,000, 3,000, 4,000, 5,000. Okay, that would be pretty fast for a Land Rover engine, but see why I bothered going all the way in a minute. Okay, so the perfect engine would have straight flat line torque right across. Very nice torque curve, although it's a straight line. It would have peak torque from 0 RPM right through the engine, right through the power band. That would give us a horsepower of exactly, because torque times speed gives us horsepower. So 0 RPM times, I don't know, let's say 100 foot-pounds of torque, it's still 0. But as we work our way along, it becomes a straight line. A neat thing about torque and horsepower that not many people understand is that they must cross at 5,252 RPM. It's just a mathematical certainty. Now, torque and horsepower really have a different relationship in most internal combustion engines. Now, this would be the ideal torque curve. We'd have max torque from 0 RPM. We could idle away up a hill or whatever we want to do. And as the engine wound up and up and up and up, we'd still have tons of torque, therefore tons of efficient horsepower. And because peak efficiency is at peak torque, the whole power band from 0 to 5,000 RPM is peak efficiency. Now, it's just not, it's not possible. It just can't really happen. The closest we can get to anything like that is an electric motor. Electric motor has a really nice torque curve. Looks something like this. Most electric motors. Starts pretty high, a little wandering, and it kind of drops off at high RPM. Giving you horsepower, really not too bad. Kind of peaks up, then it drops off a bit, then we get another little peak, and then it drops off a bit again. Again, crossing over at about 52, 52. Now these are really magic, because electric motors have peak torque, or usually, sometimes the next lump is peak, at 0 RPM, which is great for like electric vehicles. You could pull away from a stop sign with peak torque. It's not very efficient, but you're only there for a few moments because you have very little horsepower, so you're taking a tremendous amount of electrical current. But once you're up to 5, 10 miles an hour, that's really out of the picture. So this is fabulous. Peak torque at 0 RPM and a relatively long torque band. It's hard to say where peak efficiency really is in an electric motor because back EMF and other things come into the picture. But they're very nice torque curves. But we can only dream of torque curves like that. In fact, most of the auto industry would dream of anything resembling that. Here's a pretty typical torque curve for an internal combustion engine. Starts at 0, peaks at roughly around 2,000 RPM, and wanes off, giving you a horsepower curve of about, I don't know, works its way up slowly, a little lower, and again, crossing over at 52, 52. In the case of a Land Rover, peak torque is at 2,000 RPM, and it's roughly 120 foot-pounds. Peak horsepower is at roughly 4,000, and it's roughly 70 horsepower. Okay, makes sense? No problem. The only problem is peak torque, remember, is peak efficiency. So horsepower at peak efficiency, if we project this down at 2,000 RPM, is probably only about 40 horsepower. Great, 0, Pete. Ugh, gets worse and worse. I'm not really a wakeboard guy. I don't know if that's any better. Anyway, peak torque gives us only 40 horsepower at peak torque. Now, that's really not too bad, because when you're tootling up and down a little country road, you only need about 40 horsepower to get you down the road, and you're at peak efficiency, and the engine's not wound up too much. So that works out pretty well. If you only want to go about 40 miles an hour. But if you need to travel at highway speeds or tow heavy loads or pull out to pass, which is really what I'm building this truck to do, you need more horsepower. You want to drive at peak torque, but you need more horsepower. So if we take the actual numbers off of here, here I am making a mess again, and we assume the curves are really, really very similar for the 4.3, because it has peak torque at 2,000 RPM, except it's 360 foot-pounds. No, it's not. It's 230. Confusing it with small block V8. And peak horsepower at roughly 4,000 RPM of 160 horsepower. Well, that's not so bad, because we want to drive it at peak torque again. So the horsepower at peak torque is down here, and it might be, I don't know, around 100 horsepower. Which is more than a Land Rover engine ever created in its wildest dreams. So you can noodle along at highway speed, 65 miles an hour, whatever speed you really like to drive, at 2,000 RPM, which is peak torque, peak efficiency, with enough horsepower to get you down the road. You got tons of extra horsepower if you want it, but you don't need it. And besides, when you get up here, you're so inefficient that you're just pouring gas down anyway. So think peak torque. It's the magic of it. See you later.
Okay, so I wrote a little program to help me with my Land Rover gearing. I call it Rover Gear. Anyway, it's basically just a calculator for the transmission, transfer case, overdrive, differential, tire size, and engine speed, and any combination of. So basically, a stock, say, Series 3 transmission, here are the ratios. Stock transfer case, here are the ratios. We'll have no overdrive for now. Stock 4.7. Traditional 32-inch tires, and as we go through the various engine RPMs, we get our low and high ratio top speeds, as well as a graph below. So you can see, to get 65 miles an hour out of a stock Series Rover, we're running the engine at 3,700 RPM, which is pretty quick. So we can improve that with an overdrive, of course, right? So let's put a Rover drive in that, and now we can wind it down to, we're looking at this number over here, roughly 3,000 RPM, which is a big improvement. It's still kind of fast, because the 2 1/4 will have peak torque somewhere just over 2,000 RPM, being a long stroke engine, but it just won't have enough power to push the machine down the road at anything less than this speed. So at a certain point you get a diminishing return. Basically the point being, the 2 1/4 is too small an engine to run at 65 miles an hour, which is ambitious. In fact, 65 is even a little quicker than I would expect to go. My target speed is 60, 62, somewhere in there. So if we look at the combination that I'm looking at, I have the New Venture 3550, and here are its ratios, now including a 5th gear. It's still a Suffolk C, but it's got an Ashcroft in it, which changes the gearing. Now there's no overdrive. I still have stock differentials. My tires are a little taller though. They're 255/85 16s, around 33 inches tall. So to get my 66 miles an hour, this is not updated, I can get the engine right down, here we're looking at 5th gear now, to roughly 2,100 RPM. Beautifully in the peak torque band for the 4.3 V6. So this is basically the gearing that I decided to go for with my truck. I debated really about the Ashcroft. I did, because it's a 5-speed, and I thought, well, you know, I already have an extra gear. So, but if you go back to a stock transfer case, you really are winding it back up. 65.2 miles an hour at 2,800 RPM, which is not fast for the 4.3, but it's well out of the peak torque, therefore out of the peak efficiency. And again, I'm not looking for a hot rod. I'm basically looking for a truck that can tool along as efficiently as possible. Anyway, this turned out to be quite a nice little program to help me with this, and to help me explain gear ratios to some other people. And it was fun to set up. Talk to you later.